So let's image that you have to start performance testing on the project. You're absolutely new in this area, and you're in 2025. You are able to utilize GitHub Copilot, and let's look how you can succeed with this task with K6, InfluxDB, Grafana, and definitely GitHub Copilot or any other AI assistant what you can use, like Cloud Desktop, Cursor IDE, or Copilot from JetBrains, or some alternative assistant from JetBrains, or other, even GPT site. Fine. What we have here, it is some small manual how to repeat everything what I will do in this video. I will add link to the GitHub with this example into the video description, so you will be able to reproduce it. But let's figure out what you have to do before start. You have to install K6. K6, it is a performance testing tool. It's initially written on Go language, but it's provide JavaScript and TypeScript DSL on top of the Go language application, and you are able to set your tests or design your test with JavaScript or TypeScript code and run it with all power of Golang and Goroutine from your laptop or Docker container or CI/CD server, or with K6 operator in Kubernetes, or without K6 operator in Kubernetes. It's not a big deal. So you are able to run it everywhere if you want it and need to find performance leakages of performance in your application. So after that, you have to install Docker Desktop or Podman or Rancher. Three of them, it is just a Docker client. If you are a Linux user, you can install it natively via Docker Community Edition in your terminal, and everything will be work smoothly. But if you are macOS user or if you Windows user, you have to install some specific software. My recommendation is Rancher Desktop. It's free to use. It's developed by SUSE Foundation, and it's easy to install, easy to use, and no policy or license policy in top of that. Comparing with Docker Desktop, it is native Docker application for Windows and macOS, but if you are working in some kind of enterprise and your company do not support Docker Desktop license, then it's a bit illegal. So let's play fair and find some alternative. Podman, very powerful, super tool from Red Hat and IBM, but it can be a bit complex for newcomers. Fine. Also, you have installed VS Code and GitHub Copilot extension or JetBrains IDE. Maybe you already use it. If no, you can start. If no, if you don't start it, you can try it. Specifically for Java, it's most popular IDE, also very popular for JavaScript, TypeScript, WebStorm, and for Python, PyCharm. Or you can use VS Code with some extension, it's not a big deal. And GitHub Copilot, or you can also find JetBrains AI assistant and try to use assistant from JetBrains to achieve the same result. But I will present a demo with GitHub Copilot. Or you can install your favorite AI-driven IDE like Windsurf or Cursor IDE, so it's not a big deal what you will use, but in demo I propose these two variants. Okay, steps to run locally. You have to run our infrastructure locally, so you have to execute docker compose up -d, so it is detached mode, and your terminal will be free to continue. If you will avoid using -d, then you will see real-time logs in your terminal, but you have to open the new terminal window to run next command. You have manually create database into the your InfluxDB database, and InfluxDB we will use to store results from the K6. You have to add data source with InfluxDB to Grafana. You have to import Grafana K6 dashboard. You have to download swagger.json. You can do it by your browser. It is open and free to use petstore.swagger.io. We can find it in Safari easily, so it's available on public. We will test few endpoints from this user controller. You can press petstore swagger and just save it into your operation system, into your local folder, or you can use my example and do it automatically from the terminal, depending on your needs. You have to start new chat. So to do that, we have a special icon into the Visual Studio Code. So you can open it, start it, you can manage it somehow. In future, I will do some guides about it. And this is a prompt example, what we can use. So you are a performance test engineer and K6 expert. I provide OpenAPI specification for you, swagger.json, generate a K6 test using smoke test load profile. The load profile, it is some kind of different load test type. You can find more information about load test file in K6 documentation. Let's briefly look on it. Go to the K6 documentation, go to the testing guides and load testing types. Here you can find the smoke test, average load testing, stress testing, soak testing, spike testing, and breakpoint testing. In this video, I will do not guide across these topics because it's out of scope of this current video, but in the future we will check what is it and why breakpoint testing. It's not always only breakpoint testing, and it's also a capacity test and so on, and what is the saturation point of your service velocity and performance. So we will speak in future about it. Now our goal just to start, and after that AI will generate some script and you have to execute it. You have to specify that out format for your test results will be InfluxDB, and InfluxDB available on the local host port 8086, and we will use YouTube demo database. And you have to specify path to your generated script. It can be JavaScript or latest version of K6 already support TypeScript file as well. In past you have to specify some compatibility mode for it, but now it should work from the box. But it's not a goal of our video. Fine, now you know what we will do, and let's try to step by step repeat this instruction and see how it's work. First of all, docker compose app -d. Let's do it. So I successfully run it in my terminal, and you see that Grafana should be started. I pull the Docker images, and after that I will pull the InfluxDB. We have to wait a bit until it will be download from the Docker Hub, and Docker Hub, it is public registry for storing of different Docker images, and Docker image is some kind of guide what should be run inside of the container and so on. So if you are familiar with Docker, it's very simple for you. If you are new in Docker, probably in future I will record some video about how it's work. So in general, you have to understand that when you run something inside of the Docker, it's mean that you run isolated from your operation system application inside of specific container, and this is container called Docker. You can run multiple containers in your operation system, but you have to be sure that this container use different ports, because for example, if you want to run like Grafana on port 3000 and other application or some kind of another application that will use the same port, you will get a conflict and so on. Also, Docker container can be run inside of internal network, so you can isolate it from your network and do some kind of security from one side. From another side, you can provide port exposure and discover some application from the internal Docker network by access from your operation system, like localhost column 8086, we will discover InfluxDB, or localhost column 3000, we will discover the Grafana. Fine, so both of them already started. Let's open our Safari browser and type localhost 3000. I have to log in to my Grafana instance, Grafana application. As you can see in Docker Compose file, it's currently some kind of guide for Docker how to run it. So we use InfluxDB. It's pretty old, 1.8, but it's simple to use. We expose port 8086 from container to our operation system. You can modify it, but you have to, if you will modify it, you have to provide changes into the commands what we will use. And we expose 3000 port for Grafana, and in Grafana we have environment variable like gf underscore security underscore admin underscore password admin, and default admin user, it is admin. So I have to type admin login. I don't want to change the password, not now, and we inside of Grafana. Nice. Now I have to connect my Grafana to InfluxDB, but before I have to create a database inside of the InfluxDB. So to do that, I have to execute this curl request to create a database with name YouTube demo. So let's do it. As a result, I got a statement ID 0. It means database was successfully created. Nice. Let's try to connect it. To do that, I go to the connection. In data source, I have to type InfluxDB and add new data source. Okay, InfluxDB. We have HTTP localhost 8086. We know that Grafana and our InfluxDB run it inside of the Docker. So we use custom internal Docker network K6net to link it, and they are located in this. I can show you, and briefly I will do not dive into this section. So let's clear our terminal and type next Docker network ls, and you can find the list of the Docker network in my operation system. I can find my K6 Grafana InfluxDB GitHub Copilot K6net. Okay, it's very long name, so we will use ID of this network, and I will type Docker network inspect and past ID of my network. Here you can find that my network name is K6-net. Okay, and you can find that I have two containers inside, I think. Let's try to find it. Containers. So containers InfluxDB, container name is it InfluxDB, and container name Grafana. You can use IP address of internal network for this communication, or you can use container name. Both will work as well. My recommendation, use container name. It's much more human understandable. Fine. So let's go to the Grafana. Type HTTP /influxdb column 8086. Fine, and here I have to specify my database name. So it will be YouTube demo. Save and test. Works fine. Save it. Nice. Now I have to create a dashboard. And honestly, you can create your custom dashboard. And it's very interesting topic because you can achieve everything what you need. You can use the different data sources, different queries. You can use InfluxDB, Prometheus, ClickHouse. You can create a dashboard for automatically comparison of test results for different version of your service. But it's a bit complex and our goal just start. So I will import dashboard from web application what is supported by Grafana Foundation, and it is collection of already existed and set up at Grafana dashboard. So I will go to K6 dashboard Grafana Labs. How you can do it? You can easily type in your browser grafana.com, Grafana dashboards, and you will find the incredible collection of Grafana dashboards for everything what you need. If you want to monitor your message broker, your application, your Argo CD, everything, the logging, central logging system, the authorization system, your Kubernetes dashboard, everything what you need for Node.js, for Golang, for JVM application, everything you can find here. You can add some customization and achieve incredible results. Fine, I want to find something for K6, so I will type K6, start searching, and we have the different results. We have like K6 Prometheus, K6 load test result, and so on. So let's select K6 dashboard, InfluxDB. As you see, we have two of them. We have InfluxDB1, InfluxDB2, InfluxDB3, 4. You can use any of them. If you see the InfluxDB, it is your right choice because in our example we use InfluxDB as the data source, so it will work. If you will use as a data source like Prometheus, you have to set up your K6 to publish metrics to the Prometheus, and in this case you have to use another one. So in our case we will use, for example, this one for InfluxDB. So I can copy ID of this dashboard. I can download the JSON because the dashboard configuration stored in the JSON file. So I'll copy ID to clipbar and I will navigate to my import dashboard page and press load. I have to select my data source and wow, I have a dashboard in the second. Super! Now let's switch to Visual Studio Code and try to generate tests for our application. So I will use swagger.json. Let's on the minute return to the Safari and navigate. So I want to cover create user endpoint and get user by username endpoint. Fine. So it's pretty easy. You can go to the readme.md. I will copy and paste my prompt. I passed it. I will add to context file and folders. So I will add swagger.json. I will add docker compose. It's optional, you can do it or avoid it, not a problem. So let's skip it, and I will add my readme.md as well, just to add additional context, not only from prompt. And to prompt, or no, for now I will leave it as is, and do some kind of live experiment. I got information from the agent, but generation is not stopped. And let's check what we have. So the LLM return information based on the analysis that, okay, we have a swagger.json focused on create user and get user by username endpoint. We know about configured InfluxDB, and so it is a post request for user and get user by username. It's generate K6 test script. Let's keep it and review it. So we can find first disadvantages that this is not really smoke test. It can be smoke, yeah. Let's a bit change it. For example, we have 1 second, 3 second, 1 second, maybe less extended. Let's do it 5 seconds, and this 10 seconds, and this will be 5 seconds. So what it means, it's our ramp up. So our ramp up 5 seconds, 10 virtual users. After the 10 second, we will have 10 virtual users, and the last 5 seconds, we have to degrade our amount of virtual users to 0. Find, we have a threshold for HTTP request duration, and HTTP request duration, it is a latency of process send request and got a response. So 95 percentile should be less than 500, absolutely fine. We have a base URL localhost 8080, it is wrong. Our base URL is another one. Let's navigate to the Swagger. Let's try to execute it, execute simple requests, and copy paste our base URL from here. It is https://petstore.swagger.io/v2. Let's double check our tests. So yeah, I was right, and we can change the base URL to our. Fine, we change it. We have currently we have a K6 default function, what is the entry point to our tests, and inside of that we have some kind of variable create user payload. We have our headers, we have a create user response, and we use http.post. It is DSL from K6 to send post request with create user payload with our headers, and we will check that status should be 200, fine, and we have a get user by username. We create a variable username. We took value from the create user payload username field, and we will execute http.get to get user by username from our application, and we will check that status is 200, and in response we see the same username what we used to create this user file. And LLM provide examples how should looks the command to execute these tests. If you're at least able to read K6 documentation to know some metrics and so on, my recommendation, do it and run it in terminal by your own hands. Read the report from terminal, go to the Grafana and check the results. If you are not able to do it due to time, what you have, like you have a limitation of time to this task, or you don't have such skills, you can just copy paste it and set to your agent in GitHub Copilot, execute it, and provide summary report. Fine, it's pretty simple task. Now your GitHub Copilot, and due to some options to execute some commands in your operation system, able to execute it. Let's start execution. Meanwhile, it's pretty nice practice if you're faced some issue. For example, LLM provide for you some recommendation. Oh, let's try to execute this command. You try execute it, got some error. You couldn't find what is the issue. Where is the error? You can try to execute it from LLM, and in this case, LLM will take response from this command as additional context and will be able to provide some guides to you how to fix it. Maybe no, maybe it will be hallucinated, so you have to be very careful with that. Fine, and even we executed from GitHub Copilot, we got information from our tests, we got information about past tests, failed tests, a percentage, amount of total requests, succeeded requests, failed requests, percentage of failed requests, percentage of succeeded requests. We have information in HTTP requests, and so on. Execution, we have like 126 iteration, average iteration during 1.27 second, max virtual user is 10, network data received, we receive 129 kilobytes, we send 43 kilobytes, so we got some summary from the results. Nice, but let's go to our Grafana and check last 5 minutes. I will refresh it and I can see information. So I have my test, I can specify the time frame more carefully, and we have like a peak RPS request per second 16.7. We have a virtual user 10, it is max value. We have max response time 151 millisecond. We have average response time, and so on. We can scroll down and find the table of results. What we see that we have a bunch of 44 that get request wasn't succeeded, and it's look like post requests, all post request was succeeded. We can order it by request type, scroll to post, and we can see that all post requests was succeeded, but multiple get request wasn't succeeded. The most of error is 44, that user wasn't found, sorry, and so on. So here you can find information about response time, duration, or latency, sorry, like 95 percentile, 99 percentile, max response time, average response time, and so on. Nice, so we successfully start some kind of performance tests. You can try to manage it, you can try to change the test. For example, to avoid this 44 issue, we can add some simple timer between our requests. Let's do it. Yeah, because usually that when we create something, it's not always possible to retrieve this information immediately with this service. So you can repeat this execution again, and after that we will see the results. Yeah, we will execute it from the LLM side or from the agent side. So agents will use tools to communicate with my terminal into the Visual Studio Code and execute some commands in terminal currently not linked but connected to operation system, and it will execute it in my operation system. The LLM got information from the response, like this terminal report what was provided by K6 got some summarization for us, and we can go to our Grafana dashboard. Let's specify last 15 minutes, select our last tests, and we can find information about our tests. Due to extra timer inside of the test, we execute less amount of requests, and it's look like we have 200 response code. Let's order it by 200, and we still have some 44, but just visually it's look like we have less 44, and we start receive 200 requests from the get endpoint. So some user what was created was found, but not all, unfortunately. Probably we have to extend some kind of this timer between requests, but it's absolutely fine for our demo purpose. Nice. So now you're able to set up K6, InfluxDB, Grafana. You're able to use GitHub Copilot to some simple debugging and support you into the report preparation. Also, you can take a screenshot or use Playwright MCP server to open the dashboard and ask your agent to analyze the dashboard and provide more deeper performance test report based on this result. But definitely you can do it by your end, and it can be very interesting and very useful exercise for your product and for your personal experience. For this, I'm done. So thank you for your attention. Have a great day and see you in future. Bye.